This is the Amp Hour Podcast. Released June 10th, 2018. Episode 396. The Synergy Bus.
Welcome to the Amp Hour. I'm Dave Jones from the EEV blog.
And I'm Chris Gamble of Contextual Electronics.
What's up, nerd?
Hey, buddy. How you doing?
Doing all right.
Okay.
Apart from
What's
the
that?
usual crap.
Yeah? What's the usual crap?
Nothing. We might.
I'm just wondering if you're going to say it or not.
No. I've tweeted it. You know.
Dave's getting older, folks.
I'm getting older.
Dave's getting nerdier, folks.
Should we get it out of the way now?
Yes, we should.
Yeah. All right. Yep. Apparently, I need glasses.
Oh, I mean, like, I guarantee like 80% of our audience. Come on, we're all nerds here.
Yeah, I know. It's like, like every single person I know has glasses, and they're all like, most of them are younger than me. You know, it's like, you know.
No,
anyway,
I do. I wear contacts.
You know.
Yep.
So you've probably heard me, you know, complaining about it on the blog. Oh, I can't see stuff up close, you know, anymore. Like, I'm talking like within, 30 centimeters, 12 inches for you Yanks.
Yep.
Kind of all that sort of closer.
Yeah.
It becomes a bit harder to focus. And
I always like the. There is someone. Oh, it's in White Christmas. It's a Christmas movie.
Right.
One of the guys is talking about like, I'm starting to play trombone, and it's talking about like when he has to like move the paper in and out from his face to actually focus in. He talks about playing trombone with Bing Crosby.
Right.
Yeah. It's a part of life, Dave. But what's interesting there, I think, is what we were talking about before the show. Is I think, I was obviously expounding upon all of the tech that could help people as they're getting older too. I think that's a huge opportunity for people listening. Like, if you're thinking about starting a business, you're thinking about like just baby boomers. I mean, Dave, you're younger than baby boomers, but like people as they're getting older, I think assistive technology type stuff is going to be a huge thing. And I don't think much would help you other than, I guess glasses are assistive technology, right. But I think that I think there's just a huge industry there, and just to keep an eye out for it,
Definitely. No, it's no doubt.
We've talked about obviously self-driving cars on the show and your lack of confidence in them, and me coming around to that point of view lately. But I think that like that is a huge one. If that does, in 10 years, hopefully that'll help my folks. Like they're kind of, that'll probably be about the point when they won't be able to drive much anymore. So
right,
and honestly,
but
I won't want them to drive.
But then you've got to fight the crusty old and this newfangled technology,
Yeah, I talk to you every week, so man. I mean, yeah.
Which you wanted to talk about. Mm-hmm. Speaking of
crusty old technology.
Tell us where you're going and what crusty old technology you're going to be using.
I'm very excited about
this.
Yeah,
this is great.
So I think I've mentioned I will be at two events this summer. Are my main two travel things. First one is Tour Camp, which is coming up in 2 weekends, and then I'll be at DEF CON in August. But at Tour Camp, I found out today, because I just didn't read about it, there's a thing called Shady Tel, and it's only going to be, it's not doing GSM service this year. So in the past they've had like a cow or like a portable antenna service where you could put a SIM in. Yeah, I forget, that's not what they're called. Sorry.
Oh, it's an acronym, is it, or something?
Yeah, it's
anyway,
an acronym
one of those
for like a
portable cellular links. Yeah,
exactly. Yeah,
right.
They call them stingrays now too. I mean, the government ones that are like spying on people are called stingrays, I think.
Oh, okay. Right. Got it.
But yeah, so the stingrays or cows or whatever, but basically those could actually do off-brand GSM service with like special SIM cards. They won't be doing that this year, but what they will be doing, and apparently have done in years past, is they wire cabling to every tent so that you can bring an analog telephone and plug in an RJ22, 24? What's the jack type on old telephones?
RJ11. Well, no,
11.
That's no RJ11. Is that modern rubbish? No, you're talking. God, I can't remember the the three. I don't know whether it's the same in the US, but I can't remember. Like 601. I have a vague recollection of. Anyway, yes, the old-fashioned telephone plug.
Okay. The RJ11 is the one I think of, like with the gray cabling, and it's got the usually the clear plastic end. I've also the acronym today. Great. So Fabs, who's been on the show before, and I'll link to that episode. So Fabienne was talking about she's going to be up there. She was tweeting about it today, and this is kind of how I found out about it too. So all of the things that are happening, but the one that caught my eye was the POTS phone. I was like, "What the hell is POTS?" Do you know POTS?
POTS.
No. Yes. No.
Point at yes.
Plain old telephone service.
Plain old telephone service.
Yeah, I didn't know that one. So yeah, so basically they're gonna send wire
this
at each.
This is great.
Tent.
And it's not a party line, which would be the easy way, but it actually goes into a little local exchange, and you can dial a tent. I
think so. Yeah.
That is awesome. So Uncle Sam's not going to be listening. It's great.
Yeah.
As I was saying before the show, if you're going to be paranoid, go all the way.
That's right. Yeah.
Yep. That's great.
Yep.
That's great. So there will be no cellular coverage there?
I think I looked at the map today. So actually, because my job, I know about service. This is actually a pretty good resource that people might want other days of the week. It's called Open Signal. And it's a nice mapping service. I think people basically war dial, like you can get an app and you can opt in to help give coverage maps, and it just checks in regularly. So I was looking at it today for Orca Island, which is where the conference is going to be. And there's stuff like on the shore, but definitely inland from there. It's not going to have much. I don't know where the tower is. So,
right.
I'm really looking forward to it. And it's going to just be a nerdy weekend. So I'm going to, be bringing projects. I'm going to actually be giving a KiCad workshop. That's kind of interesting because I'm going to have to bring... They said there's internet as well. I'm not sure how they do the internet stuff, but...
Right. Well, I'm figuring that at a hacker camp, it's going to be like pinging through 5 anonymous routers and shit like that. Somebody's going to take that by the balls.
Either way, right?
Yeah. Someone's going to take that by the balls.
This seems like a very friendly camp.
No one's getting in here,
Right. But I don't. It's really stupid too. Like I'm like really looking forward to like having like some quiet time to like do coding and to sit down with people and do some ham radio stuff. Like because I don't really get a chance to sit down with people when they're using their radios, but just like watching people. Use ham radio stuff. Looking forward to that. Maybe do some HackRF stuff and do some SDR because I think some of the Great Scott Gadgets folks will be up there. Cool. And just learning from people and camping and making marshmallows and s'mores and nerds.
Like, s'mores. Sorry.
You don't know s'mores. No. Oh, you're killing me, Smalls.
What?
You ever seen it? The Sandlot? No.
No.
Oh, okay.
No.
You have homework now, Dave.
You're really losing me today. You were throwing shit at me before the show, and I'm just going, nope.
Yeah, it's okay.
Nope, no idea.
So s'mores are when you roast marshmallows, and then you put them onto a graham cracker with a piece of chocolate.
I don't even know what a graham cracker is.
Wow, man. We live so... Dave, the chasm is so deep between us. Yeah. First, you take the mallow, then you roast the mallow. Anyways, I will post a link and send you a link afterwards.
Right. Okay. Thank you.
Yeah. Man, you thought the glasses made you sound old.
Right. Man.
Yeah.
Yep.
So yeah, I'm looking forward to it. I mean, like,
do you think that the government or any 3-letter division of the government pay any attention to these camps at all? Do they try and like infiltrate them? Do they try and hack them to see what's going on there? Do they? Or do you think they just don't care? Come on, conspiracy theory.
I don't think it's big enough. But like,
it's not big enough.
Why would they? I mean, like maybe I would be just more likely.
Because all the talks are published online afterwards, aren't they, or something?
Well, yeah, that. But I mean, like, right. But at that point, they could just attend it. Like, so, like a big component of people that go to like DEF CON and other security conferences are working for government agencies.
Oh, okay, right, yeah.
Got it. So a lot of them, like a lot of people who go to those things, won't talk about their work simply because they're not allowed to.
Right. Okay.
So,
yep.
Yeah, I was surprised by that last year. I think they said, so DEF CON is in August. but there's B-Sides, and then there's also Black Hat. Black Hat's more. It's owned by UBM now, but and it's very corporate level.
That sounds like the death.
No, it's been going for a while. It was bought like 15 years ago, I think.
Okay.
So it's been around for. It was not started by them, but it was bought and it has continued on. But that's actually like a pay a couple $1,000s to go to it kind of thing.
Got it. Yeah.
So there are those kind of things and those kind of conferences, and I think that they continue to exist because there's the quasi academic nature of them and the just the cost of access kind of.
Yep.
Yeah.
Speaking of buyouts, you heard that Microsoft bought your favorite GitHub?
Yes. Yeah.
Are you sad?
I don't really care.
Right. As long as it doesn't change, right?
I mean, like, honestly, I saw a thing about that. There was a tweet about it. It was like, all these people are upset that Microsoft buys, the centralized service is buying GitHub, but at the same time, it's the same people that took a completely distributed architecture and paid a singular service to host that for them.
Yep.
Right. Like when GitHub goes down, everyone freaks the hell out.
Right.
And that's not what Git's meant to be. It's meant to be like, oh, you have a copy, I have a copy. There's other copies.
Oh, really? It's supposed to be a distributed service.
It's distributed. Yes.
Yeah. Okay.
Right. And that's why
And that doesn't work.
Well, it does work, right? So if you have a copy and I have a copy and we both pulled from GitHub, it's a centralized copy. But GitHub, in that case, is the official copy, right?
Oh, okay. Got it.
Yeah.
Yep. And then once it comes back online, everyone sorts themselves out.
Yeah, exactly.
Right.
Exactly.
Okay.
And there's other services built on top of it too. Like I think certain things.
That's the same as Dropbox. If Dropbox goes down, I don't care because I work from my local copy.
Right. Right, and I think that's I think that's the services that I gravitate towards these days in the first place. Of like, I don't want we've talked about cloud only on here quite a bit, right? From a PCB perspective or EDA perspective more specifically, and I think you've said similar, but like if there is a local cached copy, then that's usually fine, right? I mean, like, maybe we do or don't want to pay for the service, but I think that people usually recognize that paying for that centralized service and the updates and the whatever, that's what they're really charging for. If you have to also though have access in order to even get to the design files, that's problematic, right? No? Disagree?
I tend to. No, it's fine.
Okay. Yeah. So I just think that like Evernote's another good example. That's what I keep notes in. Yeah. I just like having, if the service is down, whatever, or if I'm on a plane more specifically.
Oh, definitely. Yeah. No, you want to work from your local copy and sync later.
Right.
For sure.
Right. Exactly. Yeah. So
that's a no-brainer. Who wouldn't? I mean, I don't. I
always
don't
lamented
understand
that,
why you wouldn't use that.
Trello is the one that I always wish that they would do that. So Trello is like a kind of like a. It's kind of like replicating Post-it notes online, but
why do you use it then if it doesn't?
I stopped using it. No, I stopped using it.
Right.
Yeah.
For that reason or for
exactly.
Combination?
Yeah.
Oh, okay.
So like the Android app allowed you to work offline, but when I was on an airplane and I wanted to keep notes on things, it just wouldn't work, Right. And I think some of it is just like how the web technologies are. I think I don't actually know, but they didn't build it like that, so it didn't work for me.
Interesting.
Yep. As for Microsoft buying GitHub, I don't, GitHub is getting pretty big too. It's not like it was some tiny thing.
No. Yeah, that was enormous.
Yeah, it was bought for $7.5 billion, I think.
Yeah, it runs half the world's coding, doesn't it? I mean,
I don't know about that, but.
Well, it has to be enormous.
I do. Here's what I do know. I know that when people are like, "Yeah, I have a Git instance," and I'm like, "Oh yeah, GitHub." They're like, "No, I host it myself, or I have other infrastructure." I'm
right.
Like,
you've got like a server. Right. You've got your own. Yeah.
Yeah, and it's like totally. That's how it's supposed to happen. That's totally possible. But I'm used to this GitHub model now, and
so large corporations would have that. They'd be running their own local instance.
Yeah. So like Atlassian is like a big Australian software company, right? They'll what is it, Bitbucket, I think? Is that what is it? What is their no, not that Bitbucket. They have another, repository type service that you can buy and host somewhere.
Okay.
Yeah.
Right.
At the end of the day, the thing I like about any of these services, and to talk about Dropbox and like you're talking about or Git or whatever, at the end of the day, I just like having tracked points.
Right.
You know, auto saves one thing, but actually having like either like the service is backing itself up, and I can go and pull one of those things based on date, or my preference is to actually be like, oh, this is the change I just implemented, and actually writing that down and saying, I just changed, I just added a bunch of new resistors to this schematic.
Yep.
You know, capture
Got
that.
it.
Yeah,
Yep.
that helps a lot.
Groovy.
Yeah.
All right.
All right. Speaking of
Next.
hardware, I've been
Speaking of hardware,
yeah.
what have you been doing?
Speaking of things that I've been adding to schematic pages, I've been working on a new layout, but I've been having some issues with I2C. This is another embarrassing
Dude, it's
confession.
2 wires, 2 pull-up resistors. How much trouble could you have? Tell us.
Famous last words, yeah. I had never really, even though I had worked with a bunch of sensors in the past, they were either serial or one wire or SPI. I had never really worked with I2C before. Or they just worked, you know.
Right.
Yeah.
Yep.
And so I've been in the throes of the I2C.
You've been troubleshooting. Did you have to pull out the Bible?
I actually don't even know what the Bible is.
The standard, like the I2C standard. Did you have to get that desperate?
Oh, God, no.
To make sure it's meeting. All right. Okay.
No. Mostly, you know, like my troubleshooting process was mostly around like, first off, just checking boneheaded things like
make sure there's a signal there.
Well, yeah, or
make
even
sure
before
it's
that.
transitioning, right?
Yeah, I was just looking at like, is the code outputting anything to the lines, right?
Oh,
yeah,
right,
I guess that's signal there.
Yeah, you scope them. Yeah.
Right. So I was playing between different platforms too. So I've been on the ESP32, and I was having a bunch of troubles with the. I was using MicroPython on it, and I was having trouble with that. And then I ended up using Arduino and pushing code through that to the ESP32. And I probably should have taken.
As a test platform, you were doing like as a debug platform.
No, well, so that was another problem. I have an ESP at 32 on board.
Yeah.
But that was giving me other problems, and so what I did is I took a known ESP32, like the Huzzah 32, which is a Adafruit Feather form factor, and just compiled for that.
Right.
So put it in Arduino IDE, had like a test program that I just basically was using the wire library, and then.
So you couldn't get I2C working on an Arduino.
Well, I could eventually, but that was right. Actually after like I was frustrated and trying to do it like all in one on this one platform that I had been building, and then I was like, no, that's stupid. I need to like make sure that my signal generator is working properly.
So you were using a hardware I2C module?
No. What do you mean by that?
Like as in like the I2C hardware is built into you weren't doing software bit banging.
I was not directly doing bit banging.
Right.
However, on an ESP32, I found out that it actually is a software implementation of I2C.
Oh, it is. Okay.
Yeah.
Got it.
So, and I was surprised by that too, especially because I was looking at, so like you look at the Huzzah 32, right, and that's the feather form factor, which I like. And on the board, it says pin 32 or pin 23 is SDA, pin 22 is SCL, so that's data and clock.
Well, if they're tying them to lines, then it's most likely using a hardware module. That's
right.
why they tie them to lines.
Right. And what I found out, though, is actually that's because the feather form factor, so like regardless of which, so this is Adafruit's form factor, right? Regardless of which processor they put on board, though, they will tie the I2C lines to those two pins.
To those pins, yeah.
Right.
Right,
and
gotcha.
so what I found out, though, is that if you go and trace that back to the ESP32, you can actually instantiate I2C on other lines, meaning that it's software-based.
Yep.
Well, not necessarily.
Not necessarily.
No, right.
It could have internal routing.
You're right. You're totally right about that.
Yeah.
I misspoke there. But I did find out it's software-based. So
Right. Okay. Right.
All right. Because I had been worried about that too. Because I was like, I've actually got three different I2C devices on board, which also complicated my design. I was trying to do like way too much at once.
And they're all on the same bus?
They're all on the same bus.
Got it.
And I hang the bus off to have other things plug in.
Right.
This is for my DEF CON badge. So, yeah. Lots of people, if people are out there listening, there's the shitty add-on, it's called, which is like an ad hoc standard that Mr. Brian Benshoff came up with. Basically, I'm not sure why he chose I squared C, but he put I squared C as the ad hoc standard, basically. So it's power, ground, and SDA, SCL, 4 pins, and this basically 4-pin header that people are now making boards for that you can then go and plug into random badges. I think there's going to be people messing up
Got it.
I squared C lines, like if you have other things on them, but I have actually now, next rev will have separate lines for those things.
It's not hard to upset an I squared C line.
It is, yeah, exactly, right? So
you do know the golden rule of troubleshooting I squared C lines.
Thou shalt check pull-up resistors.
Thou shalt lower the value of their pull-up resistors.
Aha, good rule.
When in doubt,
right.
lower.
When in doubt, throw it out.
The standard, i.e. the Phillips standard, calls for 2K2 as a nominal reference pull-up value. But when you got longer lines, higher capacitance, and stuff like that, you want to be, really, because if people don't know, it's not a totem pole driver. It's an open collector driver system. So the pull-up is what pulls the signal back high. And if you've got a lot of capacitance on your line, it takes time to charge up and you don't get a nice sharp edge and all hell breaks loose. So, you want a lower value resistor.
So a lower pull-up resistor basically dumps more current directly into that node at the
and it pulls up faster.
Device.
Yep.
Right. Yep.
So,
which is crazy because I always think about it like an I squared C line, to me, I always kind of visualize it like if you're on a bus and you're pulling like the stop line. Have you ever seen that? Like
the stop line.
There's like a line, like the bell to stop the bus. Usually there's there's like a wire that goes there. And if you think about it, like the actual actuator is usually at the front of the bus. Right. And then you're actually literally tugging down on the stop cable, I guess it would be called.
That's not a bad analogy. Yeah.
Thank you. But the idea is that the propagation to get from my arm pulling down on the line to actually activating the other end, there is some delay there, and obviously it needs to have some kind of springy force to go back up. So,
that's right. Yep.
Yeah. And so the spring to make it springier. Yeah.
That's why people slam down on that thing hard and fast.
That's right. Yeah. Right. Got to make sure you stop. Yeah.
Yeah. They've got a lower resistance. There's just less propagation delay when you pull it harder and faster.
Right. Right.
Yeah.
Yes. Nothing like an analogy.
So I love I squared C. I've written my own I squared C library.
Yeah, you'd said that.
Mentioned him before the show. Yeah, I had an idea for a product. This is way back. We're talking, could be 20 years ago now.
Right. So this was probably like a display, like a 2-line display with like a PIC controller or something.
It was like a 2-line display with a PIC controller back before microcontrollers really had I squared C modules, So
no, that's a good reference too, though. Yeah. I think that's an interesting data point too. Like you said, the Philips standard, but like they made it the standard, and they actually branded it the standard as well. And now we just talk about it like it's a Kleenex, right, type of thing, where the brand name...
you can't... To this day, I believe, you still can't use the name I squared C. It is trademarked by Philips. If you want to use it, you have to pay them a royalty. Like,
interesting.
So that's why they call
that's why
it
you say
two-wire.
Yeah, I think we've talked about that before, actually.
So, And if you wanted to use I call it I squared C and use it might have been free. There might not have been no royalty, but you had to get it officially approved by Philips to use the logo. If you wanted to use the Philips I squared C logo, then it had to be, you had to submit your chip, your whatever it was, to them. Yeah. So they evaluate it and go, yep, this meets the standard. Congratulations, here's the big stamp. You can use I squared C.
Oh, here we go. So I'm looking at the wiki page. No secret source here. Since October 10th, 2006, no licensing fees are required to implement it. However, they are required to obtain a slave address allocated by NXP.
There.
That's how they get you.
I was about to talk about that. The old school slave addresses. Because there were, once this system caught on, right, they used to use an 8-bit address, so they could have like 256-bit, 256 different chips. And when it was just a Philips standard, that was great. And if you don't know where it comes from, do you know?
I don't
know. Why they
I could probably I could read through the wiki page further, but it's probably faster to ask you.
Well, I'll tell you.
Okay.
It is. Well, except for the long, detailed historical description that I'll give. It comes from Philips used to design they were the leading supplier of chips for TV sets. And back in the day, like 70s and 80s, TV sets were the leading consumer gadget. Now it's bloody mobile phones, right? But back then, right, it was TVs were driving, the sales of everything and the components and all that sort of stuff. So Philips, they cornered the market. If you go look at any of the data books from the 70s or 80s, Philips have a TV chip data book and just all the different chips for doing all the functions in a modern quote marks TV.
So CRT level, like
CRT
color multi-scan, whatever.
Yep, they do the decoders and the everything, right?
Yeah.
Tuners, the whole works.
I was quick aside. I was watching a slow-mo's guys video the other day. They actually do. Which is a great YouTube channel if people don't know. They slowed down watching a television scan rate.
Yes.
I will link it in. It is so good.
Yeah. That's great.
Yeah.
And so they were, they had hundreds of these chips, right? And maybe not hundreds, but they had dozens and dozens of these. A full data book worth of these bloody chips. And they, and functions were getting more advanced that, hey, we want to tie these together. These chips are getting smarter. We want, a push button TV, or remote control push button fancy digitally typed TVs. And we need them to, we need these chips to switch digitally instead of having the old school knob, that clunk, when you change channels.
I know that one.
You're right. Okay.
Yes. And I was there. Maybe some of our younger listeners won't be.
And these big multi-gang switches which would handle everything for you.
Right.
So they went, we need a digital standard. And that's why they developed I2C. It's the Inter-IC communication system. That's what I2C stands for.
IC being integrated circuit, right? Integrated circuit. Between integrated circuits. I got it.
In between, and that's how they talk. But they couldn't run, in a TV. You can't just...
that's a name that came up with. That was an engineer came up with that name. Integrated circuit. That would never happen these days. It would be like the synergy bus.
Oh, right. Yeah, exactly. Yep, totally.
Yeah.
I'll pay that.
Yeah.
And they went, and of course, TVs back, you didn't have 4-6 layer boards, none of that rubbish. So you can't just route things willy-nilly. Right? So they figure, let's do this multi-drop thing. So they developed this multi-drop thing that only required 2 wires, and that was groundbreaking. So you could connect to 20 different, a modern TV might have 20 different chips in it, and you've got to join them all up. Right.
Instead of having a wire harness that has, 2 to the 10th wire, not that many,
exactly.
but
Yep. Exactly. Yeah. So, and it was very clever. And they originally designed it, hey, look, we just need to tie our own chips. We've got an 8-bit address system, 256 chips. That's plenty,
Right, right. Who could ever need more memory, right? 600K, 80K, right?
640K.
Oh, 640, right.
Yep. Famous Bill quotes. Bill Gates quote. And they and then other manufacturers went, oh shit, we'll copy that. That's a good idea. And so they came out with these clone things, and then all of a sudden, 8-bit address system wasn't enough. And Philips, once they started, we can make money from licensing this thing. It's like, they were running out of addresses to allocate to people, so they would give you a unique address. And then it got to the point where very quickly that simply they ran out of addresses. Then they had to switch to an advanced 10-bit addressing system, and then they still ran out. And then it got to the point where a lot of the chips on the market would share the address.
Yeah.
So a lot of that's why a lot of I2C chips these days still, like I2C memory, if you go look at like an 8-pin, E2 prom or whatever, that's I2C, it'll have 3 address pins on it, for example, so that you can set the address. Yeah. Whereas it used to be hard coded.
Right.
Right.
Yep.
Because Philips would allocate you that number, and nobody else on the market, in theory, could use that number. That was your address.
Which is interesting because that's also how the Bluetooth standard works. That's also how USB standard works. Like to get a truly unique address.
Yep.
That's really, you need some kind of centralized authority in order to do that. Of course, these days, Dave and I are launching blockchain synergy bus.
The blockchain.
Should have seen that one coming from a mile away.
Right. Yep.
Yeah.
We actually just got a UID. Is it a unique identifier for the USB bus?
Oh, nice. For the EV blog meter?
No, for the micro supply. that we're working on.
Oh, not the meter, the supply. Okay.
No.
Okay.
Yep. The micro
Cool.
SIM, yeah.
That's great. Okay.
We got officially allocated, so we can have one of those signed drivers,
Oh, yeah. That's great.
Those signed Windows drivers. So,
Yeah.
it's officially signed by the EV blog. We got our own number.
That's cool, man.
So, it's
Did it cost money or what?
No, we got it free. It's actually, we were surprised by that. You can actually get it free. I think we got it through one of the UART manufacturers. They offer that service. If you register with them, they will use their pool, their allocated
like a block
pool
of them. Yeah.
They've got like a block or something, and they'll
that's
give
a
you
good
one.
service, though. Yeah.
Yeah, it's great.
And you don't have to
So-
I guess you just have to keep buying chips through them in order to keep
probably.
it.
Yeah, maybe.
But at
I
this
don't
point,
know.
you're probably doing that anyways.
You're probably pretty much locked into it.
Yeah. Right.
So
Oh, cool.
anyway, so the I2C system, the inter-IC system.
That's
And,
nice. Yeah, I'm looking at the wiki page too. Like the SM bus looks like that was the derivative of it by Intel.
Yeah, there is
In the 90s. So
yeah, there's a couple of clones of it.
yeah.
Yep.
It's interesting too because like Bluetooth and USB and all these other things and I2C as well, I guess. This is like why there's so many standards at the beginning normally, right? They're all like competing standards because it's like ultimately they're trying to get mind share, right? They're trying to get it to the point where it's like they don't want to give up the trademark, they don't want to give up anything else, but they do want to be the standard, right? They want to be like the one that other people have to register
Of course they do.
with.
Everyone does.
Yeah. So that's why whenever you see multiple standards, there's money lurking behind the scenes somewhere.
Right.
Yeah.
Boy. Yep.
So, yes. So to get back to the troubleshooting at hand, so what was happening, and it was really stupid at the end of the day. So, I finally got the ESP32 outputting I2C code, no problem there. Was verifying this on a scope, and I was like, oh, I see the traffic. I know I have the data. Look, this looks like data. This looks like clock. I have it plugged in, right? And I was just monitoring it with the scope. Did you see my floating scope setup? Did I show you that picture?
No, floating scope. Are you lifting the earth?
No. Wait, let me send you a picture so we can get the real reaction.
All right.
Here. And I will post this picture.
A live reaction here.
Yes, live reaction. Where the hell is it? Oh, here you go. All right. Sending to Dave now. So floating scope, and that's... so I was just using the scope.
Right. I was going to say, is it floating in the air? And yes, it is.
It is. Yeah. It's actually. I'm surprised I never thought to do this though. Like, so basically, what I did is
cable ties.
Yeah, I just zip tied the handle of the scope underneath. Like, so I have this like metal rack.
Oh, sorry. I thought I know which scope it is. Yeah, it's the Tektronix 3000.
Yeah, the MDL 3000. Yeah.
All right.
And so, but I have this cable. So I'm pretty proud of this little setup here. Basically, I took like one of those metal kitchen racks, right? And it's actually meant for like a 3 foot high. There's just one that you put in your kitchen somewhere. And I moved all the bench stuff up, and then I mount stuff underneath it, right? So it kind of made like a little hood for my open desk here. And I'll send. There will be a picture, like I said.
Cool.
But I always kind of struggle with having everything above the bench. Like I know that your bench, you have your shelf. But I think that it just, stacking stuff too high and it kind of gets really away from you. And so I was like, oh, I have the scope right here. So, hung it underneath. I thought it was pretty clever. Yeah.
It is. That's great.
Anyways, I was using that scope, and I wasn't using like the protocol analyzer on it. I was just using the actual scope just to see the analog signal. Signals look clean. The edges look clean. That was all great. I made sure I had the clock going in the right place, the data going in the right place. You can, tell if the clock always looks like it's very regular. The data has a lot of variation there. And so I was like, I can't figure out what this is. And then finally someone's just like, well, you are looking at that on a logic analyzer, right? And I was not.
Oh,
and
no,
so,
okay, right.
Yeah, which was stupid, right?
No, it's not stupid to look at the analog waveform. That's what you should be doing.
Well,
first. You don't use an analog. You don't use the logic analyzer off the bat.
That's interesting. Okay.
No, always look at signal integrity matters.
Interesting. Okay.
That's a T-shirt.
I mean, Dave, you're talking to like me. Like that is my MO as well, because I think that that's analog, right? But once I did that, I'm like, oh, it's fine, right? I guess my misstep was I said, oh, that signal looks like it's the signal it's supposed to be. I didn't actually check what it's actually saying though, because ultimately what was happening is that so I did finally put on a logic analyzer. I have that Analog Discovery 2. I plugged that in, and what was happening was, it was just kept retrying the same address because it wasn't getting any knowledge, and that was really that was a real problem. So
That's the classic I squared C,
Yes.
NOAC. You know,
Right,
like
exactly.
it's, yeah.
Right. So I had not really dealt with NAC before.
It eventually got down to a protocol thing. Yes, you had to, once you check your first step is to check your signal integrity. If that looks okay,
Yep.
and you haven't swapped the lines and done anything stupid, and there's
Yep.
data happening there, then you've got no choice. You have to go in and protocol analyze it.
Yeah. Yep.
You know.
Yeah, and it turned out that it was actually the first board that I was working with. I must have lifted a trace or something because I just can't talk to the chip on that board. And
The
so
chip
I
was
ended
it,
up.
so you were talking. The master was talking to the slave, and the slave
right.
wasn't responding.
Yeah, I was just saying,
Naughty
nope,
slave.
nothing here.
Yep.
Well, and really, it's not nothing. I guess the response is just acknowledge or not, right? It yanks down. So
Right.
to use that bus analogy, like we were talking about before, right? If the address is correct, then so if I said address hex 77.
Yep.
Then the chip goes, it pulls down on the line. It says,
pulls
yep,
down
that's
the
me.
line, say, "Yep, I heard you. Yes,
Yep, right.
please send me more."
And
Yep.
it was not there. And
Right.
And yeah, so finally got to the point where I resoldered another board. I had thought that the new board was not working either, and then finally, I finally saw an acknowledge, and it was
Right.
And then it starts piping data like it's no problem, you know. And that's the thing. Like most people, when it just works, right? It's
Yeah.
Like until you get like I don't know what the hell my problem is. I feel like every time
I2C is more complicated than it's there's more things to go wrong.
Yeah, but it's just like the chip on the other end, the slave chip is so stupid. You know what I mean? It's basically like it's like a set of registers hanging off a bus.
These are state machines, yeah.
Yeah,
These are
exactly.
just, these aren't intelligent controllers. No, they're just dumbass state machines. Yeah.
But that's what's super frustrating though, is that like I'm like it should just be working. You know what I mean? Like
You're right. Yep.
This is like the Dave Jonesism, right? Of like I hope your project doesn't work, and it's like yes, I learned a bunch, but I didn't want to.
You're welcome.
Damn it, Dave! Like,
sorry. Yeah, just when you have to get shit done, it's like
exactly.
No, not
right. Right. Learning's meant to be when I have time, and it's never.
Right.
Yeah.
I love it. Where I didn't finish telling the story.
Oh yeah. The driver
of what I was developing a product. Right. I got this idea that I'd corner the market. Yeah. I'd corner the market for an I2C tester that you could just whack on a bus, right? And it had like a little, 2-line, as you called it at the time, like a little 2-line, LCD and everything. And it decoded the I2C bus. It told you what's going on there, faults. It was designed for like TV repair people.
Yeah,
you could just whack it on the bus and go, well, is this bus working? Is it doing shit? Are all these chips talking,
Right.
And then you can go, aha, that decoder chip over there is not talking, replace that chip.
Right.
It's like, look around there, there's something, something
right.
to do
And this
with
is
that chip.
kind of what like obviously there's a lot of stuff that does this, but this single use type of thing, that's kind of what the Bus Pirate does too, right?
Yeah, but it tries to be more universal.
It does.
Mine
You're
was
right.
was going to be like a more hard coded specific thing.
How were you thinking through like the actual like stepping back? It would just record all the messages that it saw, and then you'd kind of step back through them.
It would analyze it. It would smart analyze it for you, and it'd have a database of things that it could tell you that there's 5 chips on that bus.
Oh, I see. So it scans through all the addresses.
Scans through all the like it does everything.
Okay.
Yeah. And so I thought, that'd be useful. And then I realized the amount of work on the software side. So
that would be very software heavy. Yep.
But I wrote my own I2C driver, and it was working. It was doing the business. But it was just like a lot of it was just one of those never-ending projects software-wise.
Yep.
Whereas the bus, maybe it would have ended up something like the Bus Pirate.
Yeah. I mean, Bus Pirate's great for like it's a tool. You're never gonna get rich making a tool, right? But it's
that's right.
It's pretty universally loved. I know a lot of people that are they love the Bus Pirate. So,
but back in the day, like there were X number of TV repair tech. There were
of course
50,000 TV repair techs. If you could sell one to every TV repair tech, that's a pretty good business, right?
Well, I even remember like when you started reviewing like the Rygals at the beginning, like they didn't have protocol stuff included. Like these days,
no.
Every cheap scope has a protocol analyzer in it now.
Exactly, it's totally changed.
Right,
yeah.
and that is a true blessing though. Like
Yep.
I mean, I didn't use it at first, but like to actually have that there. So if people are out there and they are, like staring at their CRT screen and trying to decode messages themselves, it's good exercise at first, but it gets real old real fast.
Yeah.
Yeah. And so it's good to like know the shapes that you're looking at, obviously, but being able to just see like the blocks of addresses, because it's like you see 8 bits going up and down, right? If it's you see the clock going up and down 8 times, and then you see the address, you see whatever you need to see there, and that really that really helps.
But yeah, I mean, this was the days before there were, these cheap USB logic analyzers that are almost free. You can get them $10 on eBay for these rip-off logic analyzers,
Yep.
And, different world.
Different world, man. Cheap logic. Did you end up listening to the FPGA episode last week?
No, I didn't. Sorry.
Mr. Luke Valenti of Tiny FPGA. It was very good. I think that's the thing. Like, so like if people are looking for a project, like you could go and take something like that Tiny FPGA project and just go and make a decoder, right? Or make an interface.
You're right.
Yeah. Like FPGAs are great for that. So like this Analog Discovery 2 I have is basically an FPGA with a front end on it. Like that's a lot of what the low cost tools are, either micros or, FPGAs, to just make it configurable and fast and handles logic well. So, yep.
Cool bananas. Anyway, so I didn't end up cornering the TV repair market.
You were not an I2C maven, you're saying, yeah.
Could have been, shoulda, would have.
Yeah.
Been filthy rich now. Yep.
Right.
Oh, dear.
Yep.
Yeah, boy. You're right.
Well,
what else we got? Oh, speaking of well, no, it's not. But I like this. I like this chip. It's chip of the week.
Oh,
Can
sure.
we have a chip of the week?
Yeah.
Yep. Chip of the week from Diodes Inc., which you don't normally think of chip of the week would come from.
Usually not super complicated parts from Diodes Inc., but yeah.
Anyway, the PT8A2511, know it well. It's a toaster controller.
From your toaster days, huh?
I love the toaster days. I got a story about the toaster days.
The heady toaster days of the world, yep.
Which I'm sure I've told before on the Amp Hour, but I will tell again in a minute. You have to remind me.
Okay.
And it's a toaster. It's exactly as advertised. It's an SO8 package, and it's designed to go into toasters. It's got a defrost mode for frozen bread. It's got a reheat mode. And
it's a very specific pull-down pin, like...
Yeah, there's like a reheat pin, and there's a relay pin, and there's a I
think this is like a lot of other chips that are out there though too, where it's like this is a true application specific IC, right? This is an ASIC, even though it's not a super complicated one.
Yep.
It doesn't get much more specific than this.
No. And it works at 1 kilohertz. It's got an oscillator pin. Don't know if it has a built-in oscillator. You can use an external RC oscillator. I know this crystal rubbish.
Right. If you want to be like super precise, right? You should do a video with this where you get this controller and then you put like your frequency standard into it.
I put a rubidium oscillator into the toaster to time. Yep. Yeah. That's brilliant.
Yep.
It wants super accurate toast. It matters,
It does.
And a pin which shorts to ground once an active negative pulse appears at defrost. It's great. I love special purpose, but actually, it doesn't come from Diodes Inc. It comes from Pericom.
Yeah,
if you look at the data
probably
sheet,
bought them at some point.
They bought. Yeah. They bought. Anyway, Pericom looks like they own the market for toaster controllers. I wonder how much this thing costs in volume.
I'm trying to find the tweet. Someone tweeted at me. They actually bought one and then already implemented it.
Right.
On it was just a breadboard thing. They test out the chip and it worked. So it's great.
I love it. And they've got a typical application schematic and none of this linear regulator rubbish in there. They've got a 3.9 volt Zener.
Oh, yeah.
Zeners are cheap,
Yeah, you go cheaper, right. We can go cheaper.
Yep.
Yeah.
Oh, man. Yep. I'm surprised they bothered to put a back EMF diode on their relay coil. Geez, that costs a couple of cents extra.
I know, right? You know? This is a Munsing territory, huh?
Yeah. fancy, and they're literally like tap in. They use like the 3.9 volt Zener comes directly from the main. So what they're doing is taking it through the heater, right? So you got 240 volts in, right, or 110 or whatever it is, right? It goes through the heater coil. Right, so it's got the lever. It goes through the heater coil and then goes into a resistor divider. They tap off the resistor divider into a single wave diode rectifier just to rectify the AC mains. Right. I can't afford that full wave rubbish.
No,
right?
no, of course not.
Right. So half wave. Sorry, that's a single wave. Half wave is what I'm thinking of.
Well, it's a single wave rectified. If the wave's big enough, you know.
Yeah. Half wave rectified, and then it goes into a 3.9 volt Zener to power the chip and actually provide the pull up and for the LEDs and everything else. Like, it's just great.
That is awesome.
Yep.
It's crazy too, is that even like the $80 toasters that are out there have things like this in it? Because why wouldn't they, right?
Yeah, like,
how much more complicated does it need to be?
30 cents worth of parts. Yeah.
Right. I mean, the fact is, this is putting a piece of silicon into a toaster, which it could do the same thing with like what's that metal strip that. Heat sensitive.
Yes, the bimetallic strip thing, which old school ones probably.
Right,
use.
That's what the $6 toasters are, right?
Right,
because in that $6 toaster, it's like, how do you get something from China to the United States and sell it with margin for $6? And it's like, there's no electronics in there.
This one, I just love this special purpose chip. Yeah. It's great.
So I did find Edward Shin had posted about this. I sent the link to Dave. He did try it out, and
sweet.
Yep.
And it works.
It works. Yeah.
DIP 8 package, none of this SO rubbish. I love it.
Yeah, it's great. He needs to power cycle to toast again, apparently, but that makes sense, right? Because that's actually what the lever on a toaster is.
Okay, so he's a firmware engineer at Fitbit.
Yeah.
I thought Fitbit went bust. No, they got bought
not
by
Fitbit. Pebble got bought by Fitbit. So
right.
Yeah. Fitbit's still around.
Okay. That's just great.
Yeah. Well, all you need now is get an ESP8266, hook it to this thing, boom, internet connected toaster.
Oh yes, internet connected toaster. That's all the bloody world needs.
That's what you need, man. You never know.
So can I retell my toaster story?
Oh, of course, yeah. I want to hear that.
Right. I can't remember what year this was. It was maybe mid-90s or something. And, I was looking around for a job, as I always did, I was, always looking, always reading the paper. Back then, right? The paper.
Circling the potential ads with a pen.
Exactly, with a pen, and, a highlighter, Yeah, I'll call him up. And, and there was this job at, like, it was nearby, and it was like a design consulting company.
Oh, okay. Yep.
Yeah. So I thought, cool. Sounds good. It's local. And so I went in to meet the guy, and he was like, oh man, he had to be 80. I think he was an old fella. He
had glasses. You knew he was old because he had glasses. Sorry, couldn't resist. Couldn't resist.
Nice callback. I'll pay that. All right. And anyway, it doesn't matter. I just noted that he was old. Anyway, and one of the jobs was that they had this contract to design this newfangled toaster.
Oh, really?
Right? Yeah, from this company, right? This company had the patent on, instead of having elements, right, that they would have, like, heated plates, and the plates would come in and touch the side of the bread, that wasn't what their patent was for. I think their patent was for the way they cook the toast, was that they would cook it at a lower temperature for longer. And
low and slow, like barbecue.
Low and slow in direct contacts to the plates, and they could control the temperature profile just like a thermal oven. They could control the temperature profile of the toast, and apparently, like, it comes out perfectly golden every time.
Wow.
It was like perfectly consistent. Like,
I'm always toasting bread, and I'm like, it'd be great. Yeah. Is if this was slower.
Right, yeah, exactly. I know. But you get your perfect toast,
I guess,
yeah. Anyway.
I have a better, this is like a better mousetrap, better toaster.
Right.
currently at MHub, I think I'm allowed to talk to this because they work on this out in the open. Currently at MHub, the place I work out of, there is a group of people working there using machine vision to toast bread and to get the perfect toasting. So this is 20 years later. This is the only difference is just the newest technology. Right. Oh my God.
And that's really what you want is camera near a heating element.
Oh yeah,
that's what
right.
You know?
Yeah. I mean, I know some of the people working on it, and like they're doing this job for it's a client, whatever, and it's a gig. Gig's a gig,
Yeah, they've probably got millions in VC funding for this bloody widget, right?
No, definitely, I don't think so. But the problem for me is that I walk in and I'm like, it smells like toast in here. It smells delicious. Like they're just toasting all day long,
right, all day long.
Yeah,
but you've got to have millions if there's a team of contractors working on it. You've got to,
it's a unique research project. I think that's all I can say about it.
Right. Anyway, it's cool. Anyway, so I'm deciding whether or not I should take this job. They had some other stuff, but I would be the primary design guy for this toaster.
You would be the toast master. Is that right?
I would be the toast master. But back then, this was before the EV blog forum.
Of course,
right? And I won't name the forum, but I was on a forum that a engineering forum.
We all know what it is.
Usenet, it was back in the Usenet
Sci.tech.electronics, whatever it was back in the day.
I won't name them. Anyway, there is a Usenet group, and there was a famous troll on there, and he repaired, one of his jobs was repairing toasters. And I won't name him, and everyone made fun, like they'd call him Toaster Boy, and
man.
like it was just like the running joke, and it was it was like so like. Yeah, because this is the community I hung out in, and if people found out I was designing toasters,
right, you would have been the new Toaster Boy.
I wouldn't have been able to hold my head up high in the. Because it was like, it was the joke that he's so crap he's repairing toasters for a living. Right. It was one of those, right, and it was one of those derogatory, things, and it's like, I'd be the world's best toaster designer, and so I went, no, thanks, so that was the decision to actually turn down that job.
Oh, that's specifically why.
The job, that's specifically why,
Wow.
Yeah.
That's great.
I didn't want to be branded for the toaster.
Wow, guy. Dave Jones making decisions based on strangers on the internet for decades now.
Totally. But that was my community back then. Of course.
That was. Like, that's like a lifeline, right? And that's great.
Yeah, totally.
That's what's morphed into the EV blog. Well, hopefully less trolly, but I've been on the EV blog forum. It's a little trolly.
Right. Well,
it's
like trying.
It's like the most helpful trolls out there.
Right. Yeah. Totally.
We're talking to head honcho troll right now. So.
Anyway, toasted. That's great. It's just funny to hear that they're still doing it. Too, with the machine vision.
I know, right?
Man. And that you just know that shit's going on Kickstarter,
We'll see.
Yeah. I posted. Sorry, I don't get the link, but I tweeted the other day, yesterday or the day before. Once again, it's not new news. It was like from late last month or something, so it's a few weeks old. That this Kickstarter failed as for a smart headphone. What is it? The
OSIC, yeah.
OSIC, the smart headphones.
You tweeted about 6 days after I put it on the Amp Hour subreddit. So I was
did?
I was like,
okay.
I wonder where Dave heard about that. Yeah, that was an unfortunate shutdown, especially given how much friggin' money they took. And
$6 million. They
it's crazy.
Took $3 million of backers' money, plus they had another $3 million venture capital.
It is with an extremely heavy heart that we must inform you that OSIC is shutting down and will be unable to deliver the remaining headphones.
Yeah. Anyway, so apparently they're like super whiz-bang 3D.
Yeah, it was meant for like AR and VR
reality
type things.
And all VR sort of stuff.
Yep.
And so a lot of people started attacking them on the forum. And I said, hey, look, the problem is, because we talked to Jerry, right, recently about this whole thing. Once the VC people come in, right, It's like your company changes focus, right?
I don't think so.
What? Jerry's company totally changed focus once
people
they
have not
came in.
listened. I agree with that. But if people have not listened to Jerry's thing, I recommend that they go and talk to him. But here's the part. And maybe this is an argument against Jerry too. But inventing something. So this is a quote that I quoted in the comments here. Inventing something new while also developing complex hardware is expensive. The addition of stretch goals to add mobile support increased the software scope from 2 operating systems to 5, added an incredibly powerful 32-core processor on board for headphones for processing, and required us to enter into substantial business development with mobile manufacturers to support multi-channel connectivity. It ultimately doubled the size of our development. Basically, that's scope creep. Like Jerry was dealing with management stuff. Yeah. This is pure scope creep.
Well, it's not pure scope creep because once that VC money comes in, right, they go, right, we're going to put a CEO in. We want this to be a real business. Yeah. We want to have long-term goals. We want a long-term exit strategy. We don't care, like this Kickstarter thing. Okay, fine, you can still play with your little toy, right? But we want this to be a real business. And it kind of, it can change the focus of the company rather than, oh, look, we're a hungry little startup, and we're just focused on delivering the world's best headphones, and now suddenly, you've got a new CEO and a new direction, and people telling you you've got to become a real company.
I mean, it's $6 million though, Dave. Like this is
that's a lot of
Jerry
money to burn
and
through.
Rick took $1 million and lasted for a long time versus this. So I'm just thinking, this sounds like this was a experience thing. Personally, I haven't looked into it enough though. So maybe I'm being the trolly old guy now.
That's why I also think it's probably a lot of it has to do with the VC people. Said no, we want, we're going to hire all these people and we're going to turn this into a real company, and bingo, the cash burn rate just goes through the roof.
That is, if that was the problem, then yeah, but
yeah, I mean, you've got to burn through the cash somehow, right? Because I'm assuming that they didn't skip the country with the money, right? I'm assuming that they simply ran out of money and time and they just burnt it all, right? Yeah. And that's one of the ways to do it is to,
yeah, I mean, again, it brings us back to
everyone.
How do you even fix this in the first place, right? Like, they obviously promised things that they were not capable of doing. If they switched it around going from 2 processors to 5 and all these other things, obviously it was not.
And I agree, stretch goals are stupid, right? Because if you're adding a stretch goal, it's a last-minute thing
designing
you thought
in feature
about.
Creep, right?
Because my Kickstarter might be successful. Oh, I better add a stretch goal. And then you don't do the proper engineering behind that and go, well, is this a good idea? What's it going to do to my, development cycle, blah, 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 the bottom line. And you just don't analyze it. You just throw it in there as, because that's what you do on Kickstarter. Mm-hmm. You have stretch goals once you get popular, to try and make it more popular, and they just don't analyze and think about these things, and you can come a gutser.
Yep.
Right?
Well, it's a damn shame, but reminder, if people are backing Kickstarters, sometimes they go belly up.
See, if I was running that, and I promised all these stretch goals, and I suddenly realized, hey, this shit, we're targeting 5 platforms instead of 2 or whatever it was you said, then I would eventually go, right, sorry, we're going to have to fess up and go, sorry,
we're
we
just
cannot
doing
deliver
iOS
the stretch goals.
Right, they delivered. That's going to be the most money at the beginning, right? Yeah. Well, I have not done this, so I can't speak any further on it, but it sounds like
apparently they did ship some units. But it's one of those unfortunate things that they burn through the cash. Yeah. And we've talked about this before. You can get, the Valley of Death, isn't it?
What's that?
Where you... Huh?
Well, which Valley of Death?
Oh, well, the income Valley of Death. This
is the Spark Fund post of, yes.
Oh, I can't remember the exact where it came from. But there's a point where you can get not too much money, but kind of like a lot of money, but not enough.
Right. Yes.
And then
what do they call it? It's crowdfunding something.
I'm sure it's something like that. We've talked about
it was
before.
Yeah.
Yep. Yeah, you're wildly more successful than you thought, but not wildly successful in order for it to be a problem, So, there's that middle ground there where it becomes a problem.
Yep.
Yeah.
I'm trying to find it furiously. I can't find it, so oh well.
Anyway.
There is a post out there somewhere. Yeah. Well, that's a shame.
Yeah. Anyway. Yep. Oops.
Boy, we got some other stuff on here. There's a great post by Tom Anderson, who's so Tom writes for Tempo quite often.
Yep.
But he also is a longtime oscilloscope nerd, and but this is just like he also like does his own animation. So he wrote about latest USB-C, and it's definitely a great resource post. So I'm gonna link that into. Basically animations of the connectors themselves and how they mount to the board and all the cabling and stuff you can do with them, and then the speeds you can get. So just a great post by Tom. So very cool. Very cool resource for people.
Excellent.
What else is on here? Past guest, Ken Sheriff.
Oh, yeah, he's just killing it. He's killing it.
The 76477 Space Invaders sound effect chip.
From 1978.
I have no experience with that, but
oh yeah, this is great.
So basically, it's like it's like a synth, right? It has to be like a mini synth to do all the different white
sound
noise
effects and stuff like all that.
Yeah, and it's probably not many layers either, but basically, Ken goes through and he actually does the die shots and
and it's got noise generators and it's got attack and decay system blocks and things like that. Local oscillators
includes the
built
block
on
diagram too. Okay,
yeah.
So basically, you can.
Yeah.
So what do you actually have to inject
Analog
signals or
generators
digital?
No, none of this digital rubbish. What are you talking about?
No.
No.
Wait, how do you actually control this thing then?
This is analog.
So this is an analog chip, but what do you? No, you inject a random noise output from the thing. So what do you just knock it high or low and you say start now, stop now?
That's it.
Got it. Oh wow, look at these waveforms too. Okay, well we'll link it in. It is an in-depth post that I obviously have not read. So
anyway, he's reverse engineering the die,
yeah,
and he overlays block diagrams, and then he draws all the reverse engineers the block diagram, and it's just insane the amount of detail, and he's even got references at the end of his article. I want to know how long it takes probably takes him a month to do that article.
Yeah, well.
That's a shit
People
ton
have not
of work.
listened, definitely go back and listen to the episode with Ken. He's a bright dude.
Fantastic.
Any other things we should add?
That chip has its own Wikipedia page.
Does it really? Oh, wow.
Yeah. Fantastic. Sorry.
I also posted, so because I've been writing code again, oh, good Lord, I posted the Google style guide. Do you know that Google has a C++ style guide?
Probably doesn't. That doesn't really surprise me.
I didn't know they wrote C++, but I guess, I guess they do, right? I mean, I always assume that they do these high level, like, D and whatever the Go and whatever else they do there. So I was just looking at, like, I was asking around, actually, I was asking the embedded folks, like, my code, I'm always really bad at naming things when I'm writing code, like naming variables. It's just like thing 1, thing 2, as I know.
Thing 2, right?
You shouldn't do that, Chris. That's a bad idea.
Yeah.
So they had pointed me to this, and it's like this is very deep, right? So it's like there's different formats for like static members versus global functions versus local variables. Like actually having different naming types around these things, and like so like a pointer always has a certain format, and a thread always has a certain format, and all these things. So it's very very rigid in terms of this coding standard, but it's something to start from. I mean, I can develop my own, but it's kind of you have to pick something and stick with it. So
hey, we totally missed a segue
What's that?
The blowing the budget startup blowing the budget thing.
Which one?
Apparently, here's the headline. It's apparently possible to blow through $100 million building a smartphone.
Oh, yeah.
And it's like, it's...
Right. Do you recognize the name of this, too?
The name?
Yeah. So...
Of the phone?
Scroll down a little bit. For Essential, the startup founded by creator of Android, Andy Rubin, it was apparently $100 million.
Yeah.
Still not ringing a bell? That's the guy that runs Playground Global, the accelerator that Jerry was based out of.
Oh, right.
Yeah,
yes.
right.
Okay. Yes.
Right.
Yes.
So,
right.
Yeah.
Oops.
Well, no, it's fine. I mean, it was known. I mean, like, this was a known thing that, like, basically, even though even though they took on other people there and they were an investment fund, this was like funding. One of the things the fund was funding was Andy's actual project, which is the Essential Phone. And it's a gorgeous, I mean, like, this thing is gorgeous, right? It's like an aluminum phone. It
was, right?
Looks like an iPhone, right? And, but yeah, the idea was it's going to be this whole brand new thing, but like, now it's nothing, right?
So it's dead, is it?
He's trying to sell it, basically.
Oh, right.
Yeah,
okay.
Right. So, I mean, the thing is, Andy is going to keep doing this. Like, and Andy is a very talented person, right? I mean, he started Android and whatever, but once he got acquired by Android, if people don't know the Andy Rubin story as well, Android got acquired by Google. He was at Google, and then, the guy who bought all the robot companies for Google was Andy Rubin.
Right.
And then now Google has all these robot companies, including Boston Dynamics, and then Andy Rubin leaves, and then he starts Playground Global, and then he's doing this, and he's also funding, like, and power to the guy, right? Like,
but he can't be too smart if he goes into the smartphone business without a phone that has anything that really stands out from the competition.
Well, I mean, if you got hubris, you got one thing, like, I think that's the thing. Like, it's like, but it's fine, right? I mean, like, that's, if there's money behind it, then maybe there must have been some plan there that at least convinced the investors.
Right.
I'm sure that walking in a room and being like, yeah, I created Android is like a pretty big one. It's like a proof point where they're like, oh, okay. But yeah, I don't know. Like, making a phone is a big deal, and I don't know what would even make it stand out these days. Like, so there were other things on it. The Essential Phone also had had like plugins that could you could add like a camera to the back, and
I don't know. Make it just like give you like a 2 weeks battery life or something. I don't know. Target like
why not just do that?
Right. Well, I don't like don't make it so right. Well, I have a requirement for a new smartphone. A screen that doesn't break, and B, a battery that lasts like 3 or 4 days.
Okay.
And that's the smartphone I went out and buy. The smartphone that matched those two requirements for me.
Yeah.
I went out and bought that one.
Did you really? How heavy is it?
It's not that heavy. It's it's the Motorola Droid X or whatever.
Yeah.
And it's got a guaranteed shatterproof screen.
I mean, they
for
all say
5
that.
years.
Dave. Come on.
Sorry?
They all say that.
No, they don't.
Yeah, they all say shatterproof and Gorilla Glass and whatever, but it's like,
anyway,
try dropping it without a case right on a corner. We'll see.
Yeah, no, I have.
Oh yeah, on purpose.
And it's good. Yeah, it's good.
Wow.
Well, not on purpose. But
I feel bad for your future glasses.
Yeah. And the battery lasts like 3 or 4 days in the damn thing.
Yeah.
That's
great.
That's exactly what I want.
Yeah,
everything else just piss off.
But
I don't care.
you're not consumer A. You are.
Oh yeah, I know.
You are not the bleeding edge. So.
Yep. Anyway.
Yeah. Well,
my needs matter. Damn it.
Yeah.
Yeah. Whatever.
Speaking of former guest Noah Feehan will be here in Chicago for a meetup that I'm doing. So if people are in Chicago and want to go to that, it'll be on June 12th. Friendly reminder, Dave is still not telling them another meetup in Sydney, but he's going to, I'm sure.
Shut up.
He's super social. Just get David too to do it, man. He's a social guy. He's a social guy.
Not really. He's not on social media.
That's true. That's a good point.
Yeah.
Anywho, if other people are the reason I actually want to bring this up, if people are coming through town, it's a great excuse for me to do another meetup. And now there are 4 3H meetups in the world. So
cool.
One in Houston, one in Austin, one here in Chicago.
I'm not rebranding my one. Don't even ask.
That's fine. And then one in Seattle. Yeah. So there's 4. And it doesn't take much to brand yours. So if people want to start on the meetup, we will talk about it here.
Cool.
All right.
We're blowing our budget for the show.
Yeah, it's an hour.
Blowing our 100 million microamp hours or something. No.
Nice. All right. Well, there's other links on the subreddit if we missed anything.
Yep. Cool bananas.
All right, man. Talk to you soon.
Catch you next time.